Oh my gosh, you need a filter, like a TikTok filter behind the release. It identifies their face and de-blurs it if they're permitted.
Not a bad idea.
Quite useful.
That would be useful.
That would be useful.
Sounds complicated.
Think
What's
about
going
the privacy implications.
We've got one more.
Oh, yeah. You're still recording everyone, I guess, but I guess you can still use the footage, right? Because it's not being
Well, now you've got the added concern of like, oh, you're identifying their faces. So it's like, on the one hand, it's like
right, yes.
better because you're not putting the identified faces in the footage. But on the other hand, it's worse because you're now letting a computer identify all your young kids or whatever.
Yeah. If it doesn't have a name and just a picture.
I'm sure you could do it, but it doesn't.
Yeah. Oh, always, right? More problems.
Yes.
So how many students do you have?
There's about 15 over there.
Oh, no, I meant in the school.
Oh, 1,500.
Okay.
Yeah.
Okay, so what's that work out per year? Like,
Oh.
like have you got all, is it
So we
like
work
kindergarten through
No,
year
so
12?
7 to 12. In a way where so our middle school, so 7, 8, and 9,
Oh, cool.
actually have groups of students together. So I'm in a middle school community, and we have a group of 3 classes of year 7s, 3 of year 8, and 2 of year 9 in that community.
I did middle school in the US, so actually having a middle school.
Yeah. And then our senior school ones go year level, so 11, 12,
Yeah.
10, 12.
Yeah, let's do it.
Let's do it. I'm sure they're super nervous.
Going for maximum intimidation, right? Just freaking out as much as possible.
So it's just straight down this way. I saw like Shenton College on LinkedIn photo that had a whole bunch of schools.
So the objectives that I want at the end of, hopefully the end of this pipeline of the pilot is
Hey Rocky.
G'day.
Hello, hey.
Hey, everybody good and frightened?
No, it's all good.
Hello.
Did you guys want to sit at the front?
disperse ourselves.
Dude, somewhere? We can see what's going
I
on.
might. No, I was like, hello.
Hello, Renee.
Hello, Renee. Space. Yes, yeah, no,
I brought out that thing from here.
Was it Fireballs in the Sky?
No. Australia Space and School.
Yeah, so Phil is our director, and I'm his deputy.
There, okay.
Quite possibly, if it was outreach stuff, or at least I may not have been there on the day, but I certainly in the background.
Last one, do you want me to promote the stream on my...
Oh, go for it. Awesome.
Naturally shifted to the left. Left, right, to the left. am I right? I'll just start with. Oh, am I right to? You've got the. We'd like to thank, first off, welcome the Binar team. Thank you for coming down. The students have been to get their presentation ready over the last couple of months. So we're super. Welcome to staff members as well who are here today. So I'd first like to Nalak Kartij Winji Nalak Nanini Nija Buja Nalak Nanini. We respectfully acknowledge the Whadjuk people of the Noongar Nation as the traditional custodians of the land on which Joseph Secondary College is built, a place where we both come to both work and learn. We pay our respects to Noongar elders past, present and emerging, and acknowledge the contribution of Aboriginal and non-Australians to the education of all children and people. We have 3 groups of presenters today. Worked on naming their presentation yesterday. So we've got Case, Our Beatles, which is punny. You find out what they're presenting on, and the Empire Enthusiasts. So we will start with. Did you want the clicker or are you going to?
Good morning. In this case, I'm Ashley. This is Crystal. This is Chris. And our presentation is like dying.
Our problem and our driving question. Our problem, Australia's research ocean acidification. Our main focus, we're also looking at Niggly Reef and W. Our driving focus is to be able to measure the changes in the ocean and carbon dioxide levels in the atmosphere using that technology to discover ways to minimize harm to our reef systems.
Why is this question important? Our driving question that needs to be answered immediately. The Great Barrier Reef is one of the natural wonders of the world and it's dying as we speak. Once it's forever, it's imperative that we act now. Research shows that the Great Barrier Reef could vanish within 10 years. This is an emergency and we must address. We need to use the CubeSat technology available to us so that everyone who has an interest in Great Barrier Reef survival will be able to enjoy the Great Barrier Reef, a reef for come.
Are marine biologists, tourism operators, fishing companies, environmentalists, and hotel chains. The construction industry. Competition is the tube as they take samples of the ocean and test their acidification. Our design is more useful as we take the whole ocean, which tells the marine biologists
Is the acidic ocean, carbon dioxide levels in the ocean is what causes bleaching of the corals, which also causes the coral.
And what is causing a reef to be under threat? Some of the causes of a reef are storms and harsh weather, crown starfish, of increased summer sea temperature, and fossil fuel as coal, oil, and gas.
Is that we want to measure the and carbon dioxide. Able to send that, so we may not be able to identify the exact temperature in the water. Sensors in the water, like the floating buoys, that could to the CubeSat, and then back down to us. The corals are predicted to be gone by 2032 if we do not take action now. Our main idea is to save.
Objective is to place sensors around the world, particularly Niggler Reef and green coral reefs of Florida. We know that gives us the ability for sensors placing the reefs on both sides of the globe to send data to the satellite, which is then relayed back and up the States. We want to send data about from these spots set so that we can.
Are there any questions?
Oh, I wanted to just acknowledging that one of the things that I with respect to the technology and putting it in yourselves is that what I'm hearing is a real urgent issues that you see are not getting for the future. So I just wanted to acknowledge that your compelling mission statement with respect to what it is that you would like and what it is that you're working towards, I think is before we get into the details of the application itself, I just wanted to acknowledge that and also say that you will find key groups here in Australia and abroad, Florida Keys and on the other planet as well, able to and grow that knowledge base and sort of activate action, I think. So I just wanted to really acknowledge that and just to say thank you myself, and it's the first time I'm doing this as well, and it's the first time I'm doing this, and I just really make sure that you know how awesome it is. So good job. And I wanted to understand a little how are you thinking about the data you're going to get as well, and what are you out of that data to solve this question?
Well, we're going to collect the data about like the temperature of the water and like the ocean acidification. And like if the acidification levels are really high, it means like there's a high chance of the corals getting bleached. The rising of temperature is like giving us an indication of climate change is coming and the acidification is going to start rising.
Are you looking at like a baseline data set that you're looking to improve on and get a more rate, or are you looking at the differences between the sites that you've chosen?
So differences over time or different places?
Looking at differences in different places, but also over time, we're trying to see how much it has and if it going at the same rate or faster. But we're also looking at the carbon dioxide levels in the atmosphere and everything, because that also helps the coral. Yeah. Anything else?
I found it interesting that you put the Australian Institute of Marine Science as a competitor. I thought that was quite funny, but in reality, actually, collaborate with them. So I think they need to be on the same team. Can you go back to your slide that had the objective and motive?
This one?
Yeah, that one. Yeah, cool. I think CubeSat. So I think really well tailored to the things you have available. So really well done. A mission that isn't well suited to a CubeSat. So I think it shows that you've put a fair bit of work in that you've suited. And I really like that you collaborate with a school in the US. A group in Hawaii doing similar stuff. So, and they have a high. We think it's quite likely we'd be able to put school if you don't have one. So be building CubeSats. So you could even maybe share
Next we have
also, I really like coral. So.
Write something on there, Crum.
Yeah.
This might have one in a pencil case. Whiteboard marker. No, for Crum.
This is
We can do it now.
albedos. Our mission concept, the mission is to map and maintain changes to the Earth's albedo, effects on heat and input. Albedo effects.
Okay, so explain what global warming is, even though we all probably know. So basically, global warming we face today due to the use of mainly also to. And did you know, 1896, Swedish scientists realized that the rise in could basically change the structure of the Earth. In 1938, Guy Callender had connected the increasing of CO2 is what was impacting warming on the planet, and basically.
So albedo is a whiteness as known as the proportional reflection of light from white ice caps to the albedo. The albedo effect is affected by the Earth's climate, as if the Earth's climate is and there's more ice and snow, and the albedo increases, meaning more sunlight is reflected out in space and the climate decreases.
A problem in basically boils down that there isn't many active, there isn't albedo trackers around the world. How can we measure the changing albedo of the world, and how does that affect warming?
One of our final goals is to utilize the collecting data and management strategy. Our second goal is one of our final raise awareness of how the Earth's climate change. And one of our final goals, albedo's effect on the Earth's climate, and to see the impact.
Stakeholders of this mission concept are involved with global warming, passionate about helping with global warming, and like any institutions try to prevent global warming.
So design could it's a terrible photo. They won't say about it. I can't reach, but a basic design just consists of having a normal camera, an infrared scanner to pick up infrared, a GPS, and a UV camera, as it basically just involves capturing what information being sent up to the also capture having a higher albedo and infrared.
By the albedo.
Questions?
Yeah, that was great. Also,
yeah.
I think they're quite interrelated, which is really interesting. Ocean temperatures, you might need to know a bit. Has the albedo changed recently? If you can figure out what the cause is. Is it like a current of warm water, or is it outlet or something? Really big project.
You go.
I've actually got a couple of questions. First of all, you mentioned that one of the reasons you're interested in this mission is that there's not of projects in different parts of the world. Did you find any? Are there any want to try and copy some stuff from, or any? I guess a little bit more other missions that might be doing the same thing. If you found any, or if you didn't.
While researching the albedo, we did find a couple of websites. They mainly consist of information, and they did at ground level. Doesn't give us a whole review from up on seeing exactly what.
Yeah, cool. And then the second question is to follow up to that. Obviously, the all around or over a significant chunk of the world have the opportunity to look at a bunch of different places. But if you were going to pick maybe one or two sort of spots to look at as a priority, would you like to look at the albedo and measure?
Well, probably mostly Antarctica, because those are areas where it's mostly ice caps. Because of global warming, obviously they've started to melt. We want to keep it, try and get.
Yeah, so the orbit that end up in actually doesn't pass over the pole really at all. So the highest ish degrees north.
So you weren't expected to know that.
That's okay. No, that's okay.
And it's dependent upon the launch provider. We might not have told you exactly what.
That could change by then. So a little bit about picking your targets later on. I just wanted to know if you had thought about you want to look at maybe and maybe there's some stuff you can learn on what the other groups are doing. Use is changing, but spots outside would be interesting.
One of the things you also want to look at is the because of the desert.
There's also major cities around the world, big mega cities, our main from the poles.
Okay, yeah. Big cities or do as well.
Probably because of cities, maybe there would be more production areas. It has a lot of gas that can go into the air and pollute it, which also was a factor of global warming.
Maybe roads might increase or decrease the albedo, that will increase the temperature.
Stuff like rooftop. There's a lot of stuff about
While researching, we found that asphalt and, as you mentioned, rooftop play increasing the albedo, raising the temperature. This is the target was major cities.
Can you go back to your motivation slide, the objective slide, the big beginning? Yeah, cool. Heat island which is where like suburbs and cities tend to get warmer now than they just countries. You consider that like in scope? Are you guys interested in that, or you want to favour effects? That's just about what you're interested in, and you don't need to know today.
We interested that, but it might change in the future due to unknown factors, as it might be too hard to measure all of them at the same time.
No, it's cool because I think be able to make an instrument that could, at a global level, like places where you come to school. So it's really, I like that. It's interesting.
Like if we can make that data available, people can check.
Yeah, and they can like come to you and experts on it. I don't know more about it. I'll bring you up. That's pretty cool.
I was wondering, very cool. I like it. But why did you choose UV and infrared as your
visible as well?
Yeah, visible. Okay, it's visible. Okay, that makes sense.
Yeah.
So I was wondering why visible was taken out. But yeah, you had. Yeah, okay, that makes more sense.
I did a terrible photo. They've been bullying me about it.
It's alright. We'll help you make like a pretty CAD model or something.
Also, I know in this row has plenty of pictures in the roll that is like photos of whiteboards or photos of drawings on our desk. Like, that's fine. We're doing it the way that we do it.
Hello. We are the environment.
What is deforestation? Is when people make lumber to use for the land where the trees once farming, grazing, or development as a result of population growth and migration.
So, agriculture expansion, wood extraction, such as logging, harvesting wood for home fuel or charcoal, infrastructure growth, such as road construction and urbanization, are the direct drivers of deforestation.
How is deforestation affecting humanity? So, the destruction of tropical forests leads to the spread of airborne diseases, including malaria and dengue, I think it is, as well as the transmission of such diseases to humans.
What happens if deforestation, and how does it affect? What will happen if deforestation is stopped? If deforestation is stopped, increase in global warming and floods. How does deforestation affect climate change? Forests are cut down, of that released into the atmosphere, CO2.
So the idea is to measure the rate of deforestation by technology. We hope to be able to provide recommendations to biodiversity findings.
So we can use satellites, one of the tools we can use to protect forests. We can only use MODIS sensors that can provide a rapid assessment and a spatial data on deforestation and reforestation collected from satellites.
Key stakeholders in global wildlife conservation, Rainforest Foundation Norway Development Program, Conservation Society, Resources Institute.
In conclusion, quick recap. A massive problem for the respiratory cycle. With this mission, we can ensure we can measure deforestation with satellite technology, advancing in habitat.
As a closing statement, thank you for listening to the presentation. If you have any questions,
Again, another shout. Good project in with that technology. We can see a lot from just from object sensors, looking at the particular target. Curious, what particular target areas are you thinking about? Target areas are you looking at? Are you looking at the range within the of looking at bench and against what already exists?
So, one of the biggest deforestation is actually effect is, and I think something around 9 million hectares was destroyed there. There's also in Brazil and Indonesia, in the Democratic Republic of the Congo, they're all big areas where deforestation, and we want to with that technology, we want to see it's changed over time. So because everywhere where there was a forest in these places is now gone.
Any questions?
That's a really good fit for CubeSat. Yeah. I know it's not like broken. Pretty well done. Tailored. I mean, we didn't expect you to necessarily do that. Well, we're going to.
Thank you.
Yeah. And it's more on one satellite. Satellite would always have something to do. You could look at the coral reef, the sea surface temperature. If it's over a city, it could be a meter, and if it's over the country or whatever, it could be looking for. And also on the orbit that your payload is likely to go to, you can probably observe all the significant forests because not many. Yeah. So it's a nice fit for the sort of orbit that we'll probably have available for you as well.
Thank you.
I really like that it combines with all the cameras because also like infrared and very good to detect creative. Some of the cool as much of video. So it's kind of good that you guys can collaborate together.
Yeah. Like how healthy.
Yeah. It's visual infrared and red map vegetation usually. It's not environment, but cool. Thank you.
Thank you so much for listening to our presentation.
So thank you for everyone for we are going to be moving to the Discovery Centre to have a bit of a debrief where you guys with the team here and actually go through some of your presentations in a bit more detail. And show that. Yeah, go for it. Yeah.
Teach space systems stuff at uni, so stuff we might see in the future. I started out looking at meteors into the Earth's atmosphere and they burn up and they make like fireball or shooting star. That's kind of where I started working on our network. Who wants to go next?
I think I've met most of the kids already. But for anyone new, hi, I am the communication officer at the Space Science and Technology. My job is to get stuff of these people's heads and like make that happen. What I do, but also a big space nerd, which helps understanding what everyone's talking about. Tristan?
He definitely has the most t-shirts out of all of us, I'm pretty sure. I am a software engineer at Binar, so I'm working with other people that create the electronics and stuff like that. Mind, don't worry. At the very end, and then went into software engineering, and I'm combining both, which is. But yeah, all day, which some people think is not that nice, but I enjoy it. It's a lot of impact with like very little resources, which is very cool.
And your code will go.
Code will go to space, and as a space nerd, I'm very happy for that. He also. I still love, and I'm one of those nerds that didn't knew I was a nerd until I software, and now I'm like, yeah, I think I was always one. But I really
so the thing to ask Tristan about is Tristan is working, which is not working on the spacecraft itself. He's working on the payload, the science instrument that goes into it. So he has he's been doing a lot of. I answer a question in space and how I build an instrument to answer a particular question I measure. And less about like how do solar panels that. So to ask about like the science questions type. So he answer them.
And maybe yeah. That's why I like so.
Hello, I'm Ben. I'm the manager of Binar. Working on the problem at Meteors and then this thing. So the different parts of it, maybe the least interesting to some people, but the most interesting challenge and face is regulation, and how can you make sure we can do the things we want to do. So how can we unlock the permissions that we need from certain bodies.
Or Whadjuk, if it's like a launch provider.
Hi, the deputy at the Space Science Technology Centre, which is the centre we're trying to uncover the origin of the system and do research that helps exploration from space exploration. And the Binar Space Program is an enormous part of it. And one of the things we're trying to do with building these incredible technologies to help us ask some really interesting questions is to do that not just around our Earth but around our solar system as well. So that's where we're heading with all of this. For me, I ran away studying astrophysics and then travelled around the world as a science communicator and landed here in Perth about 15 years ago. I also am a giant space nerd. I wrote an email to NASA when I was your age, and they wrote back, which is because now 17, 18 years, it's a really cute little story, but I think it's still very cute even if I didn't work. Now the questions that you are setting yourself up for the way you're going down, and I so much watching these presentations and seeing what you're thinking about the questions that you want to ask and the problems that you want to solve. And no matter where you go from here onwards, a little bit, think of it as your passport to help you navigate uncertainty in our futures in all of our futures. So that's what really inspires me to see being done right now. So yes, it's a pleasure to be here, and a big shout out as well to all the support that you get to help you keep asking questions and keep solving problems.
I don't know where other folks, we're going to head over to a little bit of a one-on-one chat with you, try and dig into like, okay, how are we actually going to do this? So these are the people you'll be chatting with. I thought get to know them first. But yeah, I think that's it, sorry.
I would just like to get a group. Thank you, everyone over there. Thank you.
you guys want to stay, probably just get over. Back to row, come down to this row. Oh yeah, we can go in front of the screen.
Excellent.
You need to stand back.
Thanks a whole and I can't wait to